Okay, so we're being asked to derive the formula. To derive the formula means to figure out where it came from, okay? So to get to this point, to get this formula, okay? For sum to infinity of a geometric series. So if we want the sum to infinity, that's actually the same as getting the limit as n goes to infinity of Sn. Okay, so that's where we're starting with for our formula. So if Sn is this, okay, that's your Sn formula. Now we're going to get the limit as n goes to infinity of this. Now the important thing is that r is less than 1. Okay, the modulus of r is less than 1. That's telling us that r is a number in between 0 and 1. Okay, remember modulus or absolute value, you're only interested in the positive. Okay, the magnitude, the size of r is less than 1. That means it's a fraction. Okay, so if you just take out your calculator, let's just pretend r is something like 3/4. Okay, so if we say 3/4 to the power of 2, okay, 0.56, right, let's change it to the power of 5, okay, 0.23, it's getting smaller, change it to 100, okay, to the power, so it's 3.2 by 10 to the power minus 13, let's do 1,000, your calculator approximates it to 0, okay, if we do 10,000, 0. So the limit of any fraction to the power of infinity is going to be 0. So that's going to be really important for this formula. Okay? So what we're going to do is we're going to write as r is less than 1, r to the power of n will approximate to 0 for very large values of n. Okay? What that means is r to the power of n will approximate to 0 as n gets closer to infinity. Okay? The bigger the number this is, this thing will approximate to 0 because it's a fraction. Okay? So what we end up with is the limit as n goes to infinity of is a 1 minus 0 over 1 minus r, because your r to the power of n has approximated to 0 when you get the limit as n goes to infinity. Now 1 minus 0 is just 1, so you're left with a over 1 minus r. So you're deriving that formula, you're figuring out where did it come from. Okay, it comes from your Sn formula, and because we're doing the sum to infinity, that means you're getting the limit as n goes to infinity.